Hey team, so chapter 10 here is about quadratic functions. Okay, so quadratic functions are very, very similar to what we already been working with polynomial functions. Okay, what's different about quadratic functions is that there's two variables, right? So we have a y and an x. Right, so that's a function because it has both an x and a y in it. So this is similar to what we did back with regular linear functions with y equals mx plus b. It's just a little bit more complicated because now we're going to have a squared term and just an x term, and then a constant. Okay, we're going to work now, since we've learned factoring and things like that. Now we're going to take that and we're going to turn it into how to actually graph these functions and work through them. So today we're going to work with the most simple type of quadratic function, right, where this x term is 0. Right, so if this is 0, you don't need to worry about it. Then we're just going to have the squared term and the constant. Okay, so no matter what, when you have a quadratic function, the shape is going to be a parabola. Okay, a parabola is a U-shaped curve. It's not a straight line, so it's not quite as easy because the slope is constantly changing. So it's not quite as easy to graph as just a line. But I'll show you guys how to do it. A couple of definitions I just want you to write down in terms for you to understand is the vertex is either the lowest or the highest point. So in any curve, right, we're going to have, if you watch this little guy, right, in this curve, this highest point is going to be the vertex. If it was the other way, okay, the lowest point down here would be the vertex. All right, and then the axis of symmetry is this vertical line that cuts the parabola in half. And remember that of any vertical line is going to be something that looks like, the equation is going to be x equals some constant. Okay? So remember, all of those vertical lines are going to be an x equals graph. All right, now the coefficient a, okay, the a is in here. It's going to tell us basically how fat or how skinny our graph looks. Okay, so we're going to have like this regular graph, y equals x squared, is going to be what's called the parent function. And when a changes, right, from 1, if it gets bigger, the graph's going to get skinnier and skinnier. If it gets smaller as it gets closer to 0, so if it's a fraction or a decimal, less than 1, then the graph's going to get fatter. And if it goes negative, right, so if that a is negative, you have negative x squared, then the whole graph's just going to flip upside down. Okay, and lastly, the constant c here is going to move the whole graph up and down. So it's going to be our vertical shift that just picks up the whole graph and moves it up and down. Basically take that vertex and move it. Okay, so I'm going to show you, I think the best way to learn this stuff is just from these examples. Okay, so we're going to graph each of these and compare them to the graph y equals x squared. Okay, so I'm going to do y equals x squared in black, right? Now the way you need to do this, you got to make a table. Right, so we're making an xy table. Right, so this y equals x squared is over here in black. We're going to use -3, -2, -1. I think we could probably just get by with 2 and 1. Let's get rid of the -3. -2, -1, 0, 1, 2. Okay, so we're going to plug each of these in for x's and find out what y is. Well, if we plug in -2 for x here, what's y going to be? Well, it's going to be -2 squared. -2 times 2, or sorry, -2 times -2 is 4. So if we're at -2, we're going to plot up at 4. All right, for -1, we'll have -1 squared, which is +1. For 0, 0 squared is 0. Now, for +1, +1 squared is 1. And 2 squared is 4 again. Okay, so you see this U shape that we're creating. Right, so you can kind of just use a little curve to get that together. And it looks like that. So that's the y equals x squared graph. Now, in red, I'm going to do one for y equals 2x squared. Okay, so y equals 2x squared, I need to create a table again. X and y, -2, -1, 0, 1, 2. All right, so if we're going to do -2x squared, remember y equals 2 times -2 squared. Okay, -2 squared is 4, and 4 times 2 is 8. So this one will be 8. All right, negative 1 squared. All right, this one will look like this. All right, negative 1 squared is 1. 1 times 2 is 2. So that's going to be 2. All right, so for negative 8, or positive 8, we're going to be like up there. For 2, we'll be there. 0 is going to be back at 0 again. 1's going to be at 2. 2 is going to be at 8. Okay, so now we see we can draw our graph like this. Okay, now let's compare these. Well, first of all, let's just identify the vertex and the axis of symmetry for both of these. It's actually the same for both of them. We see the vertex down here, right, the lowest point for both of these. There is no highest point for both of these because these arrows are going to continue on forever, right? But the low point here is at 0, 0. Okay, so since the low point's at 0, 0, that's going to be the vertex. All right, the axis of symmetry is this line, comes right down the middle of both of them and cuts them in half. Okay, if you drew a line or basically cut right here or folded right here, they would land both right on top of each other. Okay, so if we were writing this out, we'd have vertex equals 0, 0, and the axis of symmetry is x equals 0. Okay, x equals 0 is that line right here, this dotted line that goes all the way through. Okay. Now, what's the similar? How would I describe or compare these two graphs together? Well, since A is changing and becoming bigger than 1, it's just going to get skinnier and skinnier. Okay, so if it was 4, it'd get even skinnier. If it was 90, it'd get even skinnier. Okay, that's what's happening there. Now, number 2 here, I still have this graph of the same exact graph for y equals x squared. Okay, nothing changes there. Keep that in black. Now to do y equals negative 1/2 x squared, I need to make an xy table. Okay, so we've got, fill out our y's. So negative 2 squared is negative 4, and negative 4 times, negative 2 squared is positive 4, and positive 4 times negative 1/2 is negative 2. All right, negative 1 squared is negative 1. So we'll have a negative 1/2 in here. 0 squared still gets us 0. Then we'll have a negative 1/2 and negative 2. Okay, so we'll fill this out. Oh, I made a mistake right here. It's supposed to be at negative 2, negative 2. All right, those are all my points. And now we can connect them. And you see that this graph is a little bit different than the one we have. So once again, the vertex doesn't change for any of these. They're both 0, 0 vertex. The axis is still x equals 0 for both of them. Right? What changes when you're comparing these graphs is this blue one is flipped upside down because a is negative. Remember when I said whenever a is negative, the whole thing's going to get flipped upside down. And it also gets fatter because this coefficient is between 0 and 1. Okay, so it's going to get fatter and it flips upside down. Let's go to some more examples. Okay, now for this one. All right, I've still got my y equals x squared graph hanging out here. Oh man, that's not good. Okay, so I still have my y equals x squared graph. And now in green. Okay, I'm going to make this xy table. All right, and you're going to see that nothing's going to change because our coefficient in front of our x squared term isn't different. All that's going to happen is we're going to shift the whole graph up 1 because that's what c does. Okay, so negative 2, negative 1, 0, 1, 2. All right, for negative 2, we're going to have 4 plus 1 is 5. Negative 1, we're going to have 2. For 0, we're going to have 1, 2, and 5. All right, so we can plot all these, 5, 2, 1, 2, 5, and draw our graph. So you should see here that this is the exact same shape. All that's happened is we shifted the graph up 1. All right, now we'll put all of that together here in number 4, and we're going to actually, we have both an a term and a c term. Okay, so we're going to do both of them together. All right, so we're going to use the same y equals x squared graph to compare to. And we'll make our table for x and y. Okay, so for this new one, you gotta be able to plug this in. All right, now what's going to happen, we can just look at this and tell a couple of things. First of all, we're going to be shifting the whole thing down 2, okay? And is this going to get wider or skinnier from our x term, or from our x squared term? Well, you see that 3/2 is a fraction, but it's bigger than 1. So because it's bigger than 1, we know it's going to get skinnier, all right? And because it's positive, it's going to be the same shape. So we're going to be shifting this whole thing down 2, and then our graph's going to get skinnier. So it's going to look something like this. Okay, let's go ahead and plot the points. So negative 2 squared is 4. 4 times 3/2 is 6. And minus 2 is 4. Now 3/2 minus 2 is negative 1/2. So that's what we'll have for that one. Negative 2 for our 0, because our x squared cancels out. Negative 1/2 again, and 4. All right, so we can plot these. We're at negative 2, negative 1/2, and 4. So we can put this together. And that's what our graph looks like. Okay, so you see that the graph moved down 2, and it got a little bit skinnier. That's pretty much all that happens. Okay, number 5, we just have to describe how the function is going to change, right, between these two graphs. All right, so without graphing it, how would we describe the change here? Well, we need to look at a couple things. First of all, look at the a term, right, to see if it's going to get any skinnier or fatter. It's not going to get any skinnier or fatter because they're both 1, right? But the c term, what happens? We start with negative 3, and then we're going up to negative 2. So what's going to happen? Well, we're moving the whole graph up 1. Shift graph up 1. Okay, that's all that's going to happen between those two. All right, now lastly, I'm going to go ahead and plot this for us. We're going to work with this negative 0.25 x squared graph, but we're not going to do the whole thing. Okay, so I'm going to plot just a couple of points for us. Okay, so we're not actually going to draw the whole graph here. Right, we're just going to work with what I have drawn. Okay, what I want to know is I want to know what the domain and the range are. Well, hopefully you recall that the domain means all x's. Okay, so what are the x's that this function is real? Okay, so we're looking at the side to side. These are the x's. Okay, so we're just looking at that. For what x's is this real? Well, we see that it starts over here at negative 3 and it ends over here at positive 3. So the domain is going to be the set of all x's such that negative 3 is less than x, which is less than 3. Okay, so our domain is between negative 3 and 3. All right, and then we'll also work with the range. Remember, for the range, we're only looking at the y's. We just want to know for what y's is this true. Well, we see that the vertex up here, the maximum, is at 0, 0. So the highest point for the range is going to be 0. All right, but we need to find that lowest point. Well, we see that it looks like it's around negative 2, but we don't know if it's quite there. So what we need to do is we need to plug in. We know that at 3 and negative 3, that's where our lowest points are. So we can just plug in 3 for x squared, y equals negative 0.25 times 3 squared. And when you calculate that out, you're going to get y equals negative 2.25. Okay, so this low part is going to be negative 2.25. And that's the domain, and that's the range. That's it.